What is slope? When we talk about slope in math, we are talking about the slant or tilt of a line. And you can think about slopes of ramps. If you build a ramp for someone who has disabilities that they can ride in a wheelchair up the ramp, or someone with a walker, the amount of tilt is called the slope. And it's the same thing when you're looking at the roof of a house. If you have a really steep roof, it has a steep slope, or if you have a lower roof, it has less of a slope. So we look at slope in a lot of things in the real world, and when we're talking in math terms, we can actually calculate what the slope is by looking at two coordinates on the line and finding the difference in the y's and putting it over the difference in the x's. So if we have two coordinates on the coordinate plane and we want to know the slope of that line, just assign one of them to be x1 and the other to be y1 and x2, y2. Now I could make this pair x2, y2 and this pair x1, y1. It won't make any difference. You'll end up with the same slope. But I do have to remember the first one has to be an x, the second one has to be a y, and the subscript numbers here have to match. So I have to have both ones here and both twos here, or vice versa. So once I've determined that, I can use my slope equation, and my y2 in this instance is -1, and then I'm subtracting my y1, which is a +3. And then for my x2, I have a -2, and then I need to subtract my x1, which is a 7. And when I calculate that, I have -1 minus 3, so that's -4, and -2 minus 7, that's -9. And when I take care of my negative divided by a negative, I have 4/9 for the slope. Now, if I want to do my x1, y1s the other way, I have 7, 3, and this time we'll call that one x2, y2, just to see that they really do come out the same. And then we'll call this pair x1, y1. Put a little line here so we can separate our work. When we do the slope equation now, or the formula, we have m stands for slope. We'll always use that for slope. M equals y2, so I'll have the 3, minus y1, so minus, and then my y1 is a -1. And then my x2, so I'll have a 7, minus whatever my x1 is, which is a -2. Notice I have a minus from the formula, and I have a minus from the sign on the x term. So 3 minus a -1 is the same thing as 3 plus 1, so it's a 4. 7 minus -2 is the same as 7 plus 2, or a 9, and so I get 4/9 also. So it comes out the exact same either way I go. One may be just a little bit easier to calculate because of those negatives, but they do come out the same. Now, what if I have a graph? I'm asked to find the slope, and I don't know any of the coordinates on the graph. There's a couple of ways that I can proceed. If I remember that slope is always going to represent the rise over the run, and you may have heard that before. The rise is always going to talk about the y direction, and the run is always going to talk about the x. And we're talking about the change in y and the change in x. So I'll put in the little Greek delta, which means change. So change in y over change in x. So I can start here at a known point. You can see I have a little dot there and a little dot there to represent these are points I know for sure on my graph. And I can start at one of them and figure out where do I have to go in the y direction to get to my next point. I go 1, 2, 3, 4 in the negative direction, so -4, that's in my y direction, and then from there, how do I get to my point in the x direction? I have to go -1, 2, 3, -3. So that'll give me positive 4 over 3. Now I can also start at my other point and go the opposite directions, which will have me go 1, 2, 3, 4, positive 4 in the y direction, and then 1, 2, 3, positive 3 in the x direction. So either way, I'll have 4/3 for my slope. Now the other way that I can do this is find out what is this point. I know it's 0 in the x direction, 1, 2, 3, 4 in the y direction, so I have a point 0, 4, or a coordinate 0, 4, and then this point has a coordinate of -1, -2, -3, -3, comma 0. Now I can use these two coordinates with my slope formula, which if we remember is y2 minus y1 over x2 minus x1. Now I can choose whichever one I want to be my x and my number 2 subscript and my number 1 subscript. So I'll choose this pair to be my 2's, just randomly, but I'm really looking at them and they're both positive, so I think it'll be easier to have them in the first position. And then I have x1, y1 for my second pair there. So if I put them into my formula, I have y2, which is the 4, minus 0, and then x2, which is 0, minus -3. Now I prefer to do minus a negative because then I know it's going to change positive and it's a little easier for me. You may like it the other way, and you could put your x1, y1s here, your x2, y2s here. So I have 4 minus 0 is 4, and then 0 plus 3 is 3. So one more time, I've verified I get 4/3 for my slope. So 3 different ways, if you have a graph, 3 different ways for you to find the slope. And this problem has some fractions, so we'd like to see if it's any different. I still have my slope formula. And I'll use this for my x1, y1, x2, y2. So my y2 is going to be 6 minus my y1, -1/2, and my x2 is -3/4 minus a positive 3. So no matter which way I chose those x1, y1s, it was going to be a little bit of a mess, but this becomes a positive, and then I have 6 plus 1/2 and -3/4 minus 3. Now I would like to combine, I'm going to take some work over here, I'd like to combine 6 over 1 plus 1 over 2, and I know I need a common denominator of 2, so I'll multiply this one by 2 over 2, and that'll give me 12/2 plus 1/2. Now if I did 12 divided by 2, I would get 6. So these are equivalent fractions, and when I add 1 to it, then I'm going to get 13/2. And my last one here, -3/4 minus 3, I'll take that over here. -3/4, we're fine with that. And I want 3 to be something built up to have 4 as a denominator. And since it has a 1, I know I need to multiply by 4 over 4. So I'll have -3/4 minus 12/4. And I can double check, 12 divided by 4 is indeed 3, so this is an equivalent fraction. And then I have -3 minus 12, so -15/4. Now we can't show our slope like this, that's just a little too messy, but we can remember that this line means divide, and so we can look at it. I'm going to slide over here a little bit. 13/2 divided by -15/4. And when we divide, we can remember to keep the first fraction, 13/2, change to multiply, and flip our second fraction. So, and I can leave the negative on top, it won't matter. And now I can see if I can reduce it all before I multiply. 2 goes into 4 2 times. 13 times -2 will be -26. and then just a 15 times 1 in the denominator. So my slope here is negative 20.